Okay, thank you, Oliver. Our next presenter is Jana Beránková, whom we all know well for having brought us together here. And Jana is a PhD student in architecture at Columbia in New York. She's also a former student of the École Normale Supérieure in Paris. She works primarily on Badiou's thought and on the links between continental philosophy and architectural theory, and in particular the events of 1968. She's also the co-founder of a young editorial press, Édition Suture, which I think will very soon be much better known because of forthcoming projects. We've also worked together quite a bit with Alain Badiou directly in New York last year, and she has brought Alain Badiou to Columbia, for example, for a number of different projects. And so, happy to present Jana's work here, and her talk today will be entitled Immanence of Truths, the Absolute Between the Singular and the Universal.
Okay, thank you very much, Nick. So I'm doing here a risky project. That means that I'll talk about a book that was not published yet. So we had the privilege to get a manuscript of this book with a few people around. And so actually I can say whatever, because you cannot check it in the book, but maybe if you hear Badiou coughing, then you can think that, okay, something is wrong. So I'll start with a brief introduction. Well, first let's say that obviously set theory as such is dealing with issues that have been present in philosophy, mathematics, or also in theology from the very beginning. For instance, I just can mention those traditional opposition. We know that mathematics and philosophy have been often intrigued by the opposition between things like a discrete infinity, such as the totality of all natural numbers that is represented in set theory by the least non-zero limit ordinal and the first infinite and still countable ordinal omega, and the continuous infinity, such as a number of points on a line visualizing the set of real numbers. Georg Cantor famously asked if the power set of omega is the first uncountable infinity. The positive answer to this question is known as the still unresolved dispute about the continuum, or the positive answer is the continuum hypothesis, obviously. So the question whether the continuum hypothesis is valid or not has been haunting mathematics until now, and its rejection by Badiou, who in this sense follows Cohen's belief, hoping that the future might bring proofs to this rather subjective intuition, is the underlying assumption of Badiou's own philosophical system. Mathematics and philosophy have been also shaped by the famous opposition about which we heard here this morning between the actual and potential infinity, first sketched by Aristotle in his Physics. We have here on the one hand the potential infinity, such as the sequence of natural numbers 1, 2, 3, 4, a group of mathematical objects where the very word infinite is defined by the fact that it never ends, and there's always one more element to be added on the list. So the potential infinity is defined by the lack of completeness. It is an infinite in the process of becoming. On the other hand, we have the notion of the actual infinity. That means the infinity as an actually completed totality, something that is completed and yet composed of an infinite amount of members, an infinity that actually is. So obviously, as you may know, for Aristotle, the actual infinity did not make much sense. and he famously rejected it while trying to solve Zeno's paradoxes. So even though there have been some exceptional dissident resurrections of the notion of the actual infinity, most of Western philosophy and theology can be characterized by its emphasis on the potential infinity and the rejection of the actual infinity. According to thinkers such as Thomas Aquinas, only God could have access to actual infinity, whereas in the real world the actual infinity could not exist. Thus, claiming that we can deal with the actual infinity was often seen as profanation. And this profanation of the sacred was fully realized only by Bernard Bolzanos, who was actually active here in Prague, as you probably know, and Georg Cantor, who turned our thinking towards the actual infinity. Thus, while Bernard Bolzano paved the way to Cantor by discovering the actual infinity in the Sensorium Dei, Georg Cantor finally made a distinction between ordinal and cardinal numbers. As you know, the cardinal numbers as being the indication of a size of a given set, whereas ordinal numbers indicate also the order of elements within a given set. Cantor named the actual infinity by Greek and Hebrew letters, such as the ordinal omega, corresponding to the cardinal Aleph 0. Then he defined the ordinal successor of this infinity, omega plus 1, the first uncountable infinite ordinal omega sub 1, and so on. Thus, by positing the existence of infinite sets, he enabled us to treat the infinite as a distinct mathematical object, as a mere abstraction of something of which we cannot arrive to the end, yet we can always put aside our incapacity and treat this thing as a mathematical object. In this perspective, counting is seen as establishing one-to-one correspondence between sets. That means pairing each of the elements of the first set with the elements of another set. As Richard Dedekind has shown, a set is infinite if any of its parts has the same size as the whole set, or if there's one-to-one correspondence between this infinite set A and a set X, which is a proper subset of A. And it was the question that Georg Cantor addressed to Dedekind, and that's the same letter we had here actually, asking him if he could pair all real numbers with natural numbers that gave birth to Cantor's famous theorem, showing that there is no one-to-one correspondence between the set of all natural numbers and the set of all real numbers. In other words, the power set of any set A is always bigger than the set A. There is no bijective function that would map each element of the set A exactly on each element of the power set PA. The cardinality of the set of all real numbers is necessarily bigger than the cardinality of the set of all natural numbers. Thus, Cantor not only brought back the notion of the actual infinity embodied in those strange signs like Aleph 0 or omega, and he enabled us to manipulate them, but he also established a hierarchy of different infinities. So if the actual infinite belonged, according to Thomas Aquinas, only to God, Cantor's Promethean gesture gave the actual infinity to human beings and their abstract reasoning. Similarly, Badiou's own Promethean gesture has been to do a radical critique of what he describes as a dispositif ontothéologique, which, and here I put the French quotes on the screen because I give you my very bad English translation. So I quote Badiou. He says that this dispositif ontothéologique saves the truth while paying the price of the absolute transcendence of the one and subordinating the finite multiplicities to the formal authority of the one infinite, or l'infini, that has been often called God. In the introduction to the Immanence of Truth, Badiou goes on by saying that, and I think it's here, one more quote, I quote, "This critique presupposes that, following Cantor, we separate the infinity from the one, claiming that all that is can only take form of the multiplicity without the one. For Badiou, God has been one of the operators of the finitude that has no monopoly on actual infinity. His new major book, The Immanence of Truth, follows on this project of the profanation of the sacred, of taking the actual infinity off from its pedestal. If the key category of being an event was the universality of truth, and that of logics of worlds was their singularity, now Immanence of Truth adds a third category, that of their absoluteness. This step was, according to Badiou, necessary, for as Badiou notes in the chapter 22 of the book, neither universality nor singularity have a constant explicit relation with the infinity. Each of these three books also relates to philosophy to a distinct mathematical field. Being an event, by focusing on ontology, is grounded in the key notions of the set theory. Logics of worlds has used theory of categories to explain the existence. And finally, the Immanence of Truth, which constitutes a connecting point between those two books, uses mainly the recent and very difficult theory of large cardinals. And here Badiou mentions a few bibliographical indications in the book, which are obviously the standard Tomasziak's textbook on set theory. Then you find mentions of Kanamori's book on the higher infinite, and of course of Hugues Boudin's work. So in this book, Badiou refers to cardinal numbers that are so large that they can approximate the entire universe of numericity. He is dealing with the highest spheres of the infinite, trying to answer in this way the question, what does it mean for a truth to be absolute? Today I would like to present you some of the key notions of this still unpublished book. To lay the ground for my explanation, I will begin by reminding the notion of the absolute class V, and then move on to talk about the hierarchy of four different kinds of infinities that Badiou distinguishes in the book. The last one, the infinity defined by its proximity to the absolute, is probably the most important one for his own philosophical system. Given the limited amount of time that I have here, I will skip the first part of the book dealing with the four different kinds of finitudes. Just think of the famous Badiou's preference of the number 4. And overall, we can say that the finite is certainly more boring than the infinite. So I focus only on the infinite here. First, let me remind Badiou's key philosophical thesis that mathematics are the modality of our access to being qua being. Being as such is composed only of inconsistent multiplicities. Badiou claims that this is not a mathematical thesis, but rather a philosophical one. It is something like a grounding axiom of his philosophy that enables him to construct the entire philosophical system. If we accept this axiomatic decision, it becomes evident that the set theory can provide a conceptual grounding to our consideration of being composed of multiplicities. In this theory, we have mathematical objects, such as sets, and one relation, that of belonging, of which all other relations are composed. However, if we look at the set theory, in what kind of universe does this theory operate? Let's say that we can create a hierarchy of sets. We begin with the smallest infinite, which is the set of all natural numbers omega, then we build its successor, then the next limit ordinal, and so on. However, is there a set of all sets? If we imagine all forms of multiplicity, do they themselves compose a set? Can we count them as one? And this is actually, I confuse it, this is actually my quote. We were quoting the same letter, that's what I wanted to say. So already in the early stages of set theory, Georg Cantor's answer has been no. In the famous letter to Richard Dedekind from the 28th of July, 1899, Cantor asked if the collection of all that is thinkable is a consistent multiplicity. That means can be counted as one and become a set. or an inconsistent multiplicity. Cantor considers the system of all numbers and describes it as big omega. This system forms a growing sequence going from 1, 2, 3, 4, omega sub 0, omega sub plus 1, gamma, and so on. So Cantor notices that this big omega cannot be a consistent multiplicity, a set of all sets, because if big omega was consistent, then as for every well-ordered set, there would have to be a number delta that would be bigger than all numbers contained in big omega that would be its successor. This delta would then be bigger than everything that is in big omega, which is a contradiction since big omega is defined as a set of all sets. Thus, big omega is an inconsistent multiplicity. There is no set of all sets. So at a higher level of infinity, of what cannot constitute a set is generally described by mathematicians as a class. So class V is not a mathematical object. It is a place where we can find all possible forms of multiple, but which itself is not a form of multiple. V is an operator. It is not a mathematical object, but that, and I quote Badiou, that from which we abstract mathematical object, or sur quoi se prélèvent des objets mathématiques, as Badiou would say. So V is the absolute class, or class absolue V, that from which we have to depart in order to think multiplicity. V is similar to what Plato describes as le lieu intelligible. That means it is the non-representable place within which all representation is being deployed. And as such, this class is stratified. It has a structure of horizon because we can create higher and higher approximations of this horizon, but we will never reach it. We can depart from nothing and then progressively ascend towards the absolute that we can never reach. Such a universe is then generally represented as a cone standing on its head. We have here the horizon V, and then the approximations of this horizon, its subclasses. Thus, for instance, if we consider a class of all ordinals, which as such belongs to the absolute class V, we see that the notion of class is based on a connection of intentional and extensional characteristics. A class is defined by its attribute, that means, for instance, being an ordinal, but it is also in extensional relationship with other subclasses. The class of all ordinals somehow belongs to the class absolue V, but obviously saying that a class belongs to another class is only a metaphor, because strictly speaking, this relation of belonging can exist only between sets. So understanding the approximation of the absolute, what does it mean that something is a large part, or a grande partie? What does the word big in itself mean, grand en soi? Or what does it mean when we say that something is close to the absolute? And that precisely is the key question of Badiou in the Immanence of Truth. This is why in this third volume of Being an Event, Badiou is using as his main interlocutor Spinoza and his notion of the attributes of the absolute. Badiou agrees with Spinoza that in order to approach the absolute, we need to pass through its attributes. Only attributes of the absolute can give us an idea of how come that something that constitutes only a part of the absolute can have almost the same power, puissance, as the absolute as such. Or, as Badiou has stated in our interview about the book, I quote, "The expressive capacity of the absolute is intelligible for us only through the mediation of attributes." If saying that we consider all the sets is the weak characteristics because it gives us a very weak understanding of the absolute, using an attribute and saying that we consider the class, for instance, the class of all ordinals, can provide us at least some grasp of the absolute, because we have a definition of what is an ordinal. We know that an ordinal is a set that is transitive and well ordered by belonging. In the Immanence of Truth, Badiou distinguishes 4 different kinds of infinities. The first infinity is the so-called inaccessible infinity, or the infinity via transcendence. This, in fact, is the least interesting form of infinity for us. I would say it's somehow, it seems to me that somehow this infinity is still somehow close to the potential infinite. It is an infinity that is transcendent because from our present system we cannot have access to it. Such an infinity can be defined only in negative manner. Thus, for instance, theology can see God as an inaccessible infinity precisely because it is transcendent to the human world. So something is inaccessible, and this inaccessibility is always related only to the perspective of a given world from which we see this thing as inaccessible. Badiou links this infinity via transcendence to the strongly inaccessible cardinal. So what is a strongly inaccessible cardinal? A strongly inaccessible cardinal kappa is, so first, it is superior to omega. That means it's superior to the set of all natural numbers. It is a limit cardinal. It is regular. That means, in mathematical terms, it means that it's bigger than the union of all cardinals that are smaller than kappa. And it is also bigger than the cardinality of the power set of any cardinal that is smaller than this strongly inaccessible cardinal. So why is this definition of strongly inaccessible cardinal interesting for philosophy? Because, as Badiou mentions, this cardinal has been for a long time seen as a limit of set theory. Because if this cardinal kappa existed, it would mean that we can then find also its corresponding class, V sub kappa, which would become a model of all axioms of the ZFC theory. And proving the existence of the inaccessible cardinal would mean also proving the inconsistency of ZFC. Consistency. However, Kurt Gödel's famous second incompleteness theorem has stated that if we have any formal system, it is impossible from within that formal system to prove its consistency. Kurt Gödel's second incompleteness theorem proved the inexistence of this final proof. Thus, Badiou reminds us here that the existence of an inaccessible infinity cannot be proved from within the axioms of the ZFC. In a way, when we are dealing with the inaccessible infinity, we are dealing with something very similar to Blaise Pascal's wager. We can only wager that the inaccessible infinity or God is, but a mere human being is unable to possess a definite proof of God's existence. Thus, Badiou links the inaccessible infinity to transcendence. As such, the inaccessible infinity is a relatively small infinity because we can have access to it only via negation. Yeah, I skipped this. The second kind of infinity that Badiou defines in the Immanence of Truth is the infinity that is defined by its indivisibility. This is indeed an old problem in Christian theology, where the unicity of God is divided into 3 figures: the Father, the Son, and the Spirit. Thus, for instance, theologians have been asking how to explain the fact that the division into these 3 figures does not diminish God's power. The infinity resisting the division is such an infinity that if we take it and try to cut it into very small parts, these parts will be always able to form a subset that will be of the same cardinality as the entire infinite set. The indivisibility is a characteristic idiosyncratic of some infinite sets. The Ramsey theorem that Badiou evokes here studied the first countable infinite omega and the possibility to divide it by 2 by realizing that if this set is divided by 2, it will be always possible to form a subset H that will belong to the same half of this divided set and will have same cardinality as the whole set, I mean the set before division. The definition of Ramsey cardinal that he evokes here goes even farther. It states that if we divide this infinite set by any number, it will always be possible to find a way of classifying the parts into which it was divided and making them into a subset of the initial set, set that will be said homogeneous to the partition. Saying that this subset is homogeneous means that the subset has the same cardinality as the initial infinite set that we try to divide. The mathematical explanation of this property of certain infinite cardinals is relatively complicated, and obviously I'm not a mathematician, so I'm somehow using, trying to approach this and give you some, as simple as I can, explanation also to me. But I can at least quote an image that Badiou gave me when he tried to explain me the meaning of the Ramsey cardinal. He told me that I can imagine it as an infinite set that is so compact and whose elements have such a density and are so close to each other that if we try to cut it into small parts in any way, there will always be huge infinite sets that will escape our cutting. So it's really the density of this infinite that makes this indivisible, in a sense. And I think Badiou is interested in Ramsey cardinals here, among all, in order to think how we can resist the oppression of contemporary capitalism today. So if, for instance, we consider any emancipative political movement, the oppression always consists in an attempt to divide the movement and to separate it into small parts, and among all, to isolate these parts. C'est saisi et séparé. If we consider a situation in which, let's say, different social groups come together to fight for the same goal, like workers, students, artists, proletarians, whatever unite, the strategy of any oppressive power will always be to combat the movement by dividing and separating these various social groups and opposing them to each other. Just look at the strike of the cheminots in France. That's really typical of any sort of social movement and the reaction of the state power. So in a sense, the division is always an operator of finitude. Thus, any truth procedure has to give birth to an infinity so strong that this infinity be at least a Ramsey cardinal, meaning that even if the oppressive power tries to divide this infinity, the parts created by this division will be always able to compose an infinite subset of the same cardinality as the infinity itself. Now let's get to the third form of infinity that Badiou describes in the Immanence of Truth. We see that each of these infinities corresponds to a different philosophical problem. If the first infinity questioned the transcendence, and the second question, the indivisibility of a truth procedure, now the third one, which is the infinity defined by large parts, ask what does it mean to say that something is close to the absolute or that something is almost absolute? What does it almost mean here? So at the beginning of my talk, I have introduced this notion of the absolute class V, which is the totality of all thinkable forms of the multiple, and which, once again, is not a set but a class. Badiou states that, I quote, "The absolute is the recollection of all possible forms of the multiple." I don't know if I have the, no, I don't have the French. L'absolu est la récollection de toutes les formes possibles du multiple. Now the question that he asks here is, are there any classes that are interior to V and then that are obviously smaller than V as such, but still can express the absolute V? What does it mean that something is presque absolu or almost absolute? How can we approximate the absolute? We can say that something is big. What does being big in itself mean? Something is big when it is compared to something small. Can we somehow approximate something that will be big in itself? So, on mathematical level, Badiou tries to answer this question by the concept of the ultrafiltre non principal cas complet. Non-principal ultrafilter complet. So this obviously sounds very mysterious. So again, let me try to at least approximate or translate a little bit what this means. So we have the notion of a filter on a set, which more or less is a mathematical apparatus helping us to distinguish small parts from the big one. It can be compared, and again, I escape into the metaphor here, but in a sense it can be compared to a kind of net that will, let's say, catch only big fish, while the small fish, like sardines, will escape. So if we have a set E, we call a filter on E a set F, composed of parts of E that has the following properties. So we have here 4 properties. First, it does not contain the empty set, because obviously the empty set as such is something very small. Oh, it's the smallest. It contains the set E. Set E is the biggest part of this thing, so it has to contain E. If part A and B belong to the filter contains also their intersection. In other words, if A is a big part and B is also a big part, their intersection will be seen as big. And the fourth one, if the filter contains part A, and A is included in part B, it contains part B too, because obviously it is logical, then B is bigger than A. So we have the filter, it's the first step. Then we move to the ultrafilter. So to make this filter into a so-called ultrafilter, we have to add a property of exhaustivity. So we have number 5 here. If we consider any part of E, it either belongs to the ultrafilter or its complementary part, that means its negation, belongs to the ultrafilter. So in a way, the ultrafilter exhausts everything what there is. Either one thing belongs to it or the opposite belongs to it. Then, if we move even farther and we want to make this ultrafilter into ultrafilter non principal, we'll say we add one more characteristics, which is that this ultrafilter does not contain any singleton. A singleton is being the set containing only one element, obviously. For Badiou, this particular mathematical apparatus called non-principal ultrafilter has a special interest because it enables us to disconnect the infinity from the one. Thus, for instance, using this non-principal ultrafilter, we can think of a political procedure that would be separated from the one entity, such as a political party or a state. And we can maybe think also of a communism that would be different from the state communism as we have experienced it in the Eastern Bloc. And finally, we get almost to the end of this. And the words cas complet, that means more or less approximating that Badiou will be using this procedure of ultrafiltering to construct a really huge cardinal kappa that will have this non-principal kappa complete ultrafilter on itself. So this is relatively conceptually complicated section of the book, which I am unfortunately not able to explain in detail here. However, if we consider the philosophical meaning of such mathematical apparatus, we could say that the ultrafiltering gives birth to a very, very huge infinite set, a set that is so huge that it exceeds the previous 2 forms of infinities and constitutes a testimony of the existence of the absolute class V. So we indeed arrive to this presque absolu, almost absolute, to a set that is so huge that it constitutes a proof of the existence of the absolute class V. To say that a truth is absolute means that the infinity of a truth is so huge that it constitutes a testimony that the absolute class V exists. The development of the concepts of this section leads us finally to the fourth and really the most difficult form of infinity, which is the infinity that can be defined by its proximity to the absolute. So this fourth infinite is really the development of the previous concepts here. Here we reach indeed the most difficult part of the book, which again I cannot explain here in detail because it would require that all my talk is dedicated only to this part of the book. However, just to approximate again, overall we could say that this Badiou's fourth infinite is in fact his theory of the attributes of the absolute. It is probably the most Spinozist part of the book, except that, unlike Spinoza, Badiou clearly states that the relationship between the absolute and one of its attributes implies the existence of a set of a very large infinite, a complete cardinal, that becomes a witness of the existence of the absolute class V. So we have a really huge cardinal here that appears as the witness of the existence of the absolute class V. Using Mostovsky lemma and Jersey Law's theorems, Badiou describes a so-called elementary embedding, that plongement élémentaire, that plays somehow a similar structural role to forcing in being an event, as forcing in being an event, the first volume. So what is elementary embedding? Again, this is very complicated, so I'm just trying to simplify a little bit. In very simplified terms, we could say that elementary embedding means that we take a transitive subclass of V, that we can call here M, like an example, you take a class of ordinals because ordinals are defined by their transitivity. And we will transform the subclass M into a model of V. So the absolute class V will be embedded in one of its attributes in the transitive subclass M. There will be a relation J between M and V. However, this relation J will not be identity. V will remain different from the attribute M and contain sets that we cannot find in M. In a way, we can describe this via an architecture metaphor. V will be embedded in M, like if you, let's say, you construct a building, you have a steel pillar that you embed into concrete to make the structure of the building hold. Right? So you have this V is really embedded into, like a steel pillar in a concrete when you build a building. So this aspect is necessary because to say that a truth is absolute does not mean that a truth procedure is absolute. Rather, the statement describes the fact that the absolute is embedded in its attribute, or in Plato's terms, it describes the relationship between the idea and what participates on the idea. Badiou states that it is necessary to, I quote, postulate that the working of a truth is being subjectively structured in a tension within a play of various distinct infinities. And the result is certainly a finite oeuvre, or in other words, its absoluteness is related to the fact that this finitude conquers the status of an oeuvre instead of being a simple waste, mot déchet, of the infinite. It is a finite result which reaches the level of its infinite causality because it inscribes itself into an attribute of the absolute. In Immanence of Truth, Badiou shows how a truth can function as an attribute of the absolute. He says, I quote, the absolute is what makes that departing from the multiplicities that are, we can think within singular truths the way how they participate absolutely on the ousia of their proper being. This leads him to finally defining a truth as oeuvre. an œuvre, or œuvre, I don't know how to translate this in English. I think the word œuvre also works in English. Œuvre is a finite fragment that, in spite of its finitude, works as an attribute of the absolute by being linked to multiple forms of infinities. Badiou states, do I have this? All truth œuvre is finite, singular, universal and absolute. Toute œuvre de vérité est finie, singulière, universelle et absolue. This finitude of an œuvre and its indexation by the infinity is what makes that a truth procedure can be embedded strictly in this world and yet participate on the absolute. And that's a little bit like the second half. At the end of the book, you have this whole dialectics of what Badiou calls déchet and œuvre, the déchet as being as something which is really a byproduct of, in a sense, of this infinite, whereas œuvre, it's something it's finite, but it's indexed to the absolute, so it has the link to multiple forms of infinities, in a sense. This finitude of an œuvre and its indexation by the infinity is what makes that a truth procedure can be embedded strictly in this world, and, as I said, yet participate on the absolute. And overall, the immanency of truth is very much the exploration of the inner composition of truths, enabling that a truth can touch the absolute and the universality, and that the universality can, as such, manifest itself within the singularity. So, in a sense, we really have to see the immanence of truth as a connecting link between being an event and logics of worlds. It is the most Spinozist of Badiou's books, a book that is, among all, an exploration of the attributes of the absolute. It is a book questioning the way how we, as mere finite human beings, embedded within this world M, can still have access to the absolute V and the mysteries of the actual infinities. It is a book that I would say makes Badiou's system complete and consistent by trying to complete somehow the lacunae in his thinking. And I would say also a book whose terribly sophisticated philosophical mathematical apparatus will be a constant source of intellectual joy, pain, and suffering and sorrow in the next decades.
Great, thank you, Jana.